Okay, example 1, we're finding a tangent line implicitly. For part A, if x squared plus y squared equals 25, we're going to find dy dx. In part B, we're going to find an equation of the tangent to the circle x squared plus y squared equals 25 at the point 3, 4. So the first thing we're going to do is we're going to go ahead and solve for solution number 1. Okay, so for solution number 1, we're going to take a look at the equation it's given in part A, which is x squared plus y squared, which is equal to 25. Okay, now when we solve implicitly, that means we're going to differentiate both sides of the equation. So that means that we're going to differentiate by saying that we're going to take the derivative with respect to x of the left side of the equation, which is x squared plus y squared, and then we're going to take the derivative with respect to x of the right side of the equation, which is 25. Okay, so then what that means is we're going to be taking the derivative with respect to x of x squared plus the derivative with respect to x of y squared, which is equal to the derivative with respect to x of 25. Okay, now remembering that y is a function of x, and then using the chain rule, okay, what does that tell us? Well, when we take the derivative with respect to x of y squared, okay, we're going to get the following. So, in part 4, we know that the derivative of x squared is 2x. Okay, now we're going to find the derivative with respect to x of y squared. Okay, well, what this equals is the following. We are going to have the derivative with respect to y of y squared times dy over dx. Okay, and then that's going to equal the derivative with respect to x of 25, which is a constant, which is 0. So now what we're going to do is we have 2x plus, well, the derivative with respect to y of y squared is 2y, and then we're multiplying that by dy over dx, and that's equal to 0. And so now what we want to do is we want to solve implicitly, meaning we're solving for dy over dx. So we're going to isolate that. So we're going to subtract 2x to both sides. So we have 2y times dy over dx, and that's equal to negative 2x. And then if we divide both sides by 2y, then what we get is dy over dx, which is going to equal negative x over y when we simplify the 2's. So therefore, this gives us implicitly the derivative. Okay, so this is part A of our question. So what we've done in part A is we found dy over dx. Now in part B, we want to find an equation of the tangent to the circle x squared plus y squared equals 25 at the point 3, 4. So in part B, what we want to do is we're looking at the point 3, 4. Okay, so that means that we know that x is going to equal 3 and the value of y is going to equal 4. So we're going to plug that into our derivative. So dy over dx is going to equal negative x over y, which is equal to negative 3 over 4. So what does that tell us? Well, that tells us that the slope is negative 3/4. So when we're using the point slope form, y minus y1, which is equal to the slope times x minus x1, we know that y1 is 4. We know that the slope is negative 3/4. And this is times x minus 3. So now let's go ahead and solve. So if we distribute, we got negative 3/4 x plus 9/4 x. Okay, so if we want to make this into a particular equation, so again, this is the point slope form. Okay, and if we want to simplify this a little further, we have 4 terms. So we can multiply everything by the value of 4. So that means we're going to get 4y minus 16, which is equal to negative 3x plus 9. So if we combine all the variables on the left side of the equation and all the constants on the right side, we end up with 3x plus 4y, and if we add 16 to the 9, then we get 25. So we can write it in that form as well. So therefore, that tells us that the equation of the tangent to the circle are the following 2 equations. So that is solution number 1. Okay, now let's take a look at solution number 2. So if we want to look at solution number 2, okay, in part B, what we want to do is we're going to take the equation x squared plus y squared, and that's equal to 25. And then what we're going to do is we're going to solve for y. So if we solve for y, then we should get y is equal to plus or minus the square root of 25 minus x squared. Okay, now we know that the point 3, 4, if we take a look at the point 3, 4, right, if we graph that, okay, now is that going to be in the upper part of the circle or the lower part of the circle? Well, that means that this point is on the upper semicircle, and if that's the case, then we're going to consider then the positive version of this. So this would be y, which is equal to the square root of 25 minus x squared. Okay, so we're going to consider then now the function. Okay, we're going to consider the function now y equals, we're going to call it f of x, which is equal to the square root of 25 minus x squared. Okay, and now we can then use the chain rule. So we can differentiate by using the chain rule. Okay, so by doing that, we're going to say that this is f of x, which is equal to 25 minus x squared to the power of 1/2. And so now what we're going to do is, in order for us to find f prime of x, okay, recall that n is going to be 1/2 times 25 minus x squared. And then if we take 1/2 and then we subtract 1, it's going to give us negative 1/2. And then we're going to multiply it by the derivative of the inside function. And the inside function is 25 minus x squared. Okay, so now when we take the derivative of the inside function, then what we're going to get is 1/2 times 25 minus x squared to the negative 1/2 times the derivative. Here, 25 minus x squared is going to give us negative 2x. Okay, now let's go ahead and rewrite that. So we're going to rewrite this okay, this derivative is now what's going to be in the numerator? Well, in the numerator, we're going to have negative 2x. In the denominator, we have 2 times 25 minus x squared to the positive 1/2. And if we simplify that a little bit further, then we're going to get negative x over the square root of 25 minus x squared. So therefore, there is the derivative of our function. Okay, now let's go back to part 3. We know that the point 3, 4 is on the upper semicircle. So now we need to look at the value of x, which is 3. So we're going to evaluate this function at f prime of 3 and then plug it into our derivative. So that means it's going to be negative 3 over the square root of 25 minus 3 squared. Well, that gives us negative 3 over the square root of 16, and so we end up getting negative 3/4. Okay, and so again, what happens is that now we know what the slope is. The slope is m, which is equal to negative 3/4. And again, we're looking at the point 3, 4. And then what that happens is now we're going to end up getting, we're using the point slope form, we're going to get that or that equation. So we get the same slope like we did over here and the same point. Okay, now let's make note. Now the expression dy over dx equals negative x over y in solution 1 gives a derivative in terms of both x and y. It is correct no matter which function y is determined by the given equation. So for instance, for y is equal to, we have dy over dx, which is equal to negative x over y, which is equal to negative x over the square root of 25 minus x squared. Whereas for y is equal to g of x, which is equal to negative square root of 25 minus x squared, we have dy over dx, which is equal to negative x over y, which means we're taking a negative times an x over the negative square root of 25 minus x squared, which gives us the positive version of x over the square root of 25 minus x squared.